Good afternoon, students. So I would like to talk about the 4.1 to 4.4 study packet for trig. It's all about the graphing with transformation of sine, cosine, tangent, cotangent, secant of cosecant function. Okay, so now we'll take a look at that, some of the problems. So the one that I circle. So here's the packet. If you guys don't like the template, you can always sketch the graph on your own template, or you can just customize the scale. So let's say that you don't like those type of scale, the given scale, you can always cross them out and then put in your own scale. Okay, so this one half, that's the amplitude. So I don't want to make the graph so short, for the amplitude. So let's just change the scale. So this one is like all integers. So let's just make it 1/2 like this. And then up here, 1. And then 1.5. Down the bottom, similar. So 1/2, negative. And then this one, -1. And then -3/2. Or -1.5. So the amplitude for this one obviously is 1/2. The value b, so you need to show the word like this. 4. So period, 2 pi over 4, which is what? Pi over 2. So one's full cycle, so from 0 to pi over 2, so from 0 to pi over 2. And then half of the distance, so then that'd be pi over 4. And then this one, pi over 8. And then this one here, 3 pi over 8. And then we do know that's a sine curve, so it started at 0, 0. The next position, pi over 8, so it reached all the way up to 1/2. And then this one go back down to 0, all the way down to -1/2, and then back to 0. So it's a roller coaster. Again, so try to learn the way to customize the scale. So whatever the one that you found, amplitude, the value b, the period, sometimes the phase shift. So depending on those elements, and then you can come up with your own scale. Okay, so now let's look at that, something else. So you see like a variety of problem here, basic form, alternate form, standard form, ultimate form, all that. So the next one, so this one looks like it's an ultimate form of cosine. But the thing is that the 1/2 has not been factored out yet, so we need to take out the 1/2. So y equals 1/2. Cosine of, so cosine of 1/2 times theta plus 5 pi over 2. Well, because that you took out 1/2. Since we took out 1/2, so 1/2 times 5 pi over 2, 5 pi over 4. And then minus 1. Again, identifying the element, so the value of a, if that's not shown, the coefficient here, it's 1. The value of b, it's 1/2. So that means the period, 2 pi over 1/2, and that would be 4 pi. And the value of h, 5 pi over 2, it's negative. And then the value of k, it's -1. And then you want to do the one cycle test. So for the one cycle test for cosine, it's always from 0 to 2 pi. So put in that 1/2 times theta plus 5 pi over 2 here. So multiply by 2 for each term, so we got 0 less than or equal to theta plus 5 pi over 2. And then it's less than or equal to 4 pi. And then subtract 5 pi over 2, so -5 pi over 2. Less than or equal to theta. And then less than or equal to 4 pi minus 5 pi over 2, so it's 8 pi over 2 minus 5 pi over 2. Then that would be 3 pi over 2. Again, change the scale, so instead of starting with 0, you can start it with -5 pi over 2. So just cross out all those radian. And then this one, 3 pi over 2. So half of the distance, right between 3 pi over 2, -5 pi over 2, then that'll be well, let's see, subtract. So -2 pi over 2, so -pi divided by 2, so it's -pi over 2. And then half of the distance here, -3 pi over 2. And half of the distance here. So 1, 2, 3, 1, 2, 3. Combine them, so it's negative, well, it's positive 2 pi over 2, which is pi, divided by 2, so pi over 2. So 0 is right here. And cosine, so let's see, the amplitude, so we do know that it's 1. Okay, again, customize the scale if you want. So this one is kind of low, so let's convert that to 1 like this. Just cross them out. So let's say 1, 2, and then 3. And here's negative 1, negative 2, negative 3. So start with the parent graph without any kind of vertical translation. So this one, it's a cosine, so that means we started at 1. That negative 5 pi over 2. The next position here, negative 3 pi over 2, goes all the way down to 0. And this one at negative pi over 2. This one, it goes all the way down to negative 1. And then back to 0. And then this position here, back to 1. Again, this one is just a parent graph, so it's dotted. Like that. And then with that, negative 1, so the vertical translation, so 1 unit down. So 1 unit down, so that would be 0 here. 1 unit down, goes all the way down to negative 1. This one goes all the way down to negative 2. Again, all the positions, 1 unit down. And then connect them. Okay, so just like this. So it's pretty easy. You try to do that with the one cycle. Without doing the one cycle, then that'd be a little bit tough because you have to shift the graph, doing all those kind of translation. Okay, so now let's see what else that we got for the rest of this. As you can see that throughout the whole packet here, so there's some basic form. Basic form, those are pretty easy to deal with. There's no need to put in the one cycle. But once you see the standard, alternate, ultimate form, so try to do the one cycle test. And then for 16, so this one is tangent. So the way to come up with the one cycle for tangent is always from negative pi over 2 to positive pi over 2. Okay, so for the one cycle, I'll put it right on this side, and then the rest of the element, I'll put it right here. So negative pi over 2 to pi over 2, the VA. And then this one, you probably want to rewrite it as y equals 1/2 tangent of 1/3 times theta plus 5 pi over 2. Again, since we take out 1/3, so this one, what's left here, divided by, multiplied by 3, so we got 5 pi over 2. So 1/3 times 5 pi over 2, 5 pi over 6, minus 1. So starting with the value of a, the scalar, so it's 1/2. The value of b, which is 1/3. So the period, got to be careful. The way to find the period is pi over b. So it's pi over 1/3, which is 3 pi. And then the value of h, according to what we wrote here, so it's negative 5 pi over 2. And then what else? The vertical translations, negative 1, 1 unit down. And then try to do the one cycle test. So we got 1/3 times the quantity of theta plus 5 pi over 2. So multiply by 3, so we do have negative 3 pi over 2. It's less than theta plus 5 pi over 2. It's less than, multiply by 3, so 3 pi over 2. Subtract 5 pi over 2, so we do have negative 8 pi over 2. Well, we're going to reduce it. And then theta, it's less than negative 2 pi over 2. So this one is negative 4 pi. It's less than theta. It's less than negative pi. Well, the thing is that because everything's being shifted to the left-hand side, negative 5 pi over 2. So right here, negative 4 pi. Cross out all those scale because you want to recustomize it. So this one here, negative pi. And let's see what else. Okay, this one you can change that, all those scale, all the scalar, all those value. And we do know that the initial position is the first vertical asymptote, so VA dotted. And then this position here, it's also the vertical asymptote. Because according to the inequality, it's not included. Okay? And then half of the distance between negative 4 pi to negative pi, then that'll be negative 5 pi over 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So halfway through. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, right here. Negative 5 pi over 2. So we do know that's a 0. And half of the distance right here, then this position would be considered negative 8 pi over 2, negative 5 pi over 2, negative 13 pi over 4. And then half of the distance right here, negative 7 pi over 4. Okay, so this one is 0. And let's see. Well, this one is 1/2. So normally this one, if that the value of a is 1, so it's 1. But right now it's 1/2, so let's just set up the scale here. 1/2, 1, and then 3/2. Down here, negative 1, negative 1/2, negative 1, and then negative 3/2. So at this position, then that'll be 1/2. But it's 1/2 minus 1. So that turns out to be negative 1/2. And then 0. So 0 minus 1, then that'll be negative 1. Again, you want to put in those transformation. And then let's see what else. And then this position is supposed to be negative 1/2. So negative 1/2 minus 1, negative 3/2. So all the way down here. So eventually, so the final graph is going to be what? It's a vertical, it's a horizontal stretch. So it's going to be like this. Okay, I can always extend that to VA. And perhaps you might want to start out with the parent function first, if that's a parent function. So that's all the way up here, 1/2. Okay, let's use different color. So this one is right at zeros, 1/2, and then negative 1/2. So for the parent function, it's like this. But now everything's being shifted 1 unit down. So minus 1, minus 1, minus 1. Alright? Okay, so now that's tangent. What about the one for cotangent? Okay, so here's another one. So cotangent, the way to do the one cycle test. So this one is from 0 to pi, because the parent graph of cotangent from 0 to pi. So again, find out the rest of the elements. So y equals 4 cotangent of 1/3 theta plus 4 pi over, well, just 4 pi, because we took out 1/3, minus 2. Check that, 1/3 times 4 pi over 3. So the value of A, 4, and the value of B, 1/3, and the period, so pi over 1/3, which is 3 pi, and then the value of H, negative 4 pi, and the value of K, negative 2. So try to do the one cycle. So we do have, well, you can put either one of those quantity. So theta over 3 plus 4 pi over 3. Subtract 4 pi over 3, so we got negative 4 pi over 3. Less than pi theta over 3. It's less than pi minus 4 pi over 3. Then that'll be negative 3 pi over 3, which is, well, let's see. It's, hang on a second. So that one is 3 pi over 3 minus 4 pi over 3, so it's negative pi over 3. Okay, got to be careful with the way to subtract those fractions with the radian, pi. And now let's see what else. The 3, we can cancel out the 3. So multiply 3 on each term. So we got negative 4 pi. It's less than theta. It's less than negative pi. So this one, we customize the scale. So 0. Well, negative 4 pi, not 0. And then negative pi. And also we don't like this kind of y-axis scale here. So again, at those positions, we do have the VA. So this one is a dotted line. Here's another dotted line with a 1 cycle of cotangent. Okay, this one should be straight, kind of tilted a little bit. And then the midpoint here, so negative 4 pi to negative pi, so negative 5 pi over 2. And then half of the distance right between. So this one would be negative 8 pi over 2, negative 5 pi over 2, so negative 13 pi over 4. And then over here, half of the distance right between. So negative 5 pi over 2, negative pi, so negative 2 pi over 2, negative 7 pi over 4. Okay, so cotangent, again, sketch the parent function first with that 4, so customize the scale. So 2 unit down, so 4, so let's see. So we got 2, 4, just use that original scale, don't want to cross that out. So 2, 4, and 6, so I'm just rewriting it. So negative 2, negative 4, negative 6. So without the vertical translation, so that the original one, so at this position is cotangent. Cotangent is like a reflected cubic curve. So that means at this position it's supposed to be 4 unit up, right up here. And then this one is 0. And then down the bottom here, then that'll be negative 4. But now with the vertical translation, well, let's just connect those dots first, parent function. Again, reflect the cubic curve. And now minus 2. So 4 minus 2, then that'd be 2. 0 minus 2, negative 2. And then negative 4 minus 2, negative 6. And then simply just connect them. And that would be the final graph. So that one is for cotangent. And now the last two that I'm going to show you, secant and cosecant. So you guys just watched that lecture video, the one that I did for 4.3. So I'm sure I mentioned about the way to sketch the graph of secant and cosecant. So this one is just a refresh. Okay, so for 23. So instead of using the template here, so I'm going to put it to the new slide for this one because it's going to be a lot more work that I need to show. Okay, so let me just snip this one. Okay, so for number 23. Okay, so I'll put it right here. Okay, so this one we do have the ultimate form. Again, this one, if you just rewrite it, so it's y equals 1/2 secant 1/2, take out 1/2 on top. And then theta minus 11 pi over 3. Because 1/2 times 11 pi over 3, 11 pi over 6, plus 1. Identifying the elements, so the value of A, the scalar, 1/2, or the initial positions for the vertex, the y value, so it's 1/2. And then what else do we know? The value of B, which is 1/2. The period, 2 pi over 1/2. So going back to 2 pi again, because that's based off the function of the reciprocal cosine. So which is what, 4 pi. And then for the value of h is obvious. So it's 11 pi over 3 shifted to the right. And then the value of k, it's up 1. So now without doing a one cycle test, this one is kind of difficult to figure out the initial positions, the final position. So let's try the one cycle test. If that's a secant, so that means we started off on 0. And then it finished all the way up to 2 pi. It's just like the one cycle test for cosine. And then putting that theta over 2 minus 11 pi over 6. So add 11 pi over 6. So we got 11 pi over 6 on the left. Less than or equal to theta over 2. Less than or equal to, well, this one is written as 12 pi over 6 plus 11 pi over 6. So 12 pi over 6 plus 11 pi over 6. Then that'd be 23 pi over 6. Okay, so it's a weird radian. And then multiply everything by 2, so we do have 11 pi over 3. Less than or equal to theta. Less than or equal to 23 pi over 3. Okay, multiply each term by 2. So 23 pi over 3, 11 pi over 3. So now we need the x-axis, the y-axis. So this time you can just customize your own scale. Okay, so going back to the solid line here. Okay, so here's 11 pi over 3 all the way to 23 pi over 3. Okay, so secant. And started with that, the parent graph of cosine. So half of the distance between 11 pi over 3, 23 pi over 3, the midpoint here, then that would be considered, let's see, 34 pi. 34 pi over 3 divided by 2, 34 pi over 6. And you might be wondering, we can reduce? Yes, certainly we can reduce. But so far, we just want to keep it this way first. Okay, so now let's see what else. Half of the distance right in between. So this one multiplied by 2 top and the bottom, 22 pi over 6. Plus 34 pi over 6 divided by 2. So then that would be considered 56 pi over 12. Yeah, certainly you can reduce. This one you just want to reduce. So reduce it, 17 pi over 3. And this one reduce it, so this one divided by 4 top and the bottom, 14 pi over 3. So this one just keep adding 3 pi over 3, 20 pi over 3. Okay, so started with the parent graph for cosine. So this one, the initial amplitude or the initial position for the vertex is what? 1/2. Okay, so 1/2, 1, and then 3/2. So started right up here. Again, just the reciprocal functions, and then 0, and then negative 1/2. 0, 1/2. Because secant is based off the graph of cosine. And now another thing that we notice, so at those zeros, what happened? Those are the vertical asymptotes. So VA. So we need to dot the line again. At those zeros, 0. Okay. And now what happened at those max and min? So 1/2. So 1/2 plus 1. Then that would be considered 3/2. So this point is actually being shifted all the way up here. Okay, let's use different color because that's going to be the final graph. And then this point right here is also being shifted. So -1/2 plus 1, then that would be 1/2. And then this one too, so it's being shifted 3/2. So that means at those vertices, we can just sketch the parabola. This one is just a halfway through, but don't forget about that. It's 1/2. So if the scalar factor is less than 1, but it's greater than 0, so that means a horizontal compression. So that means the graph would be a little bit fat. Okay, so it's going to be like this. And this one too, so facing downward. And the other half. So just like that for secant. Okay, so now let's see the last one. Okay, so going back to the template. And the last one, 27. So again, just want to snip this one and put into the new slide for this one so we can get more space. So anytime that you deal with that ultimate form, so it's a lot more work you need to show. Okay, so that's what you expect on the test. Okay, so let's see right here. Okay, so 27. Again, this one can be written as y equals, it's a non-factor form for the ultimate. So this one can be written as 3 cosecant of, take out that 2. So theta minus, so take out 2, so we do have 4 pi over 6. You're probably wondering, we can reduce it? Yes. But just want to check the work, because once you multiply out the 2, so then this one turns out back to what? 4 pi over 3. And then minus 2. So the value of A, so that's 3. The value of B, that's 2. Period, 2 pi over 2, which is pi. And then H, so it's 4 pi over 6, 2 pi over 3, after you reduce it. And then K, which is -2. And then do the one cycle test. So one cycle test for this one is from 0 to 2 pi. But the things that 0 and 2 pi, they're not included. Why is that? Because the VA, so those positions, those are the VA. And then put in 2 theta minus 4 pi over 3. So add 4 pi over 3 first. So 2 pi plus 4 pi over 3. So this one is 6 pi over 3 plus 4 pi over 3. So 10 pi over 3. And let's see what else. Multiply by 3. No, divided by 2. So divided by 2, so we do have 4 pi over 6 less than theta less than 10 pi over 6. And then reduce. 2 pi over 3. It's less than theta. It's less than 5 pi over 3. Okay, so we need the x-axis and the y-axis once again. Back to the solid line here. Okay, so 2 pi over 3, 5 pi over 3. Alright, so another thing that I want to do, find out the midpoint, so set it out for interval. So 7 pi, combine them, so 7 pi over 3 divided by 2, so 7 pi over 6. And half of the distance here, 4 pi over 6, 7 pi over 6, 11 pi over 12. And then right here, combine them. So this one is 10 pi over 6, 17 pi over 12. Because that's 7 pi over 6 plus 10 pi over 6. So 17 pi over 6 divided by 2, 17 pi over 12. And then we do know that this one is based off the sine curve with the reciprocal. So the sine curve and also the amplitude is supposed to be what? 3 right here. 1, 2, 3. negative 1, negative 2, negative 3. So if that's a sine curve, so you started at 0, and then all the way up at 3, and then 0, there's 1 down here, negative 3, and then 0. Again, it's a sinusoidal curve for the parent, the reciprocal function. But again, at 0, so you see the VA. Okay, so let's use dotted line again. VA, all the zeros. VA, all the zeros. So for those you might be wondering how I can sketch the graph so fast, because that I do recognize all the parent functions. Because basically it's all about using the parent function. If you don't recognize the parent functions, simply using that XY table or using transformations, finding the new positions, and that's going to take forever. Okay, so please don't do it that way. And then this one's supposed to be 3 without the vertical translation, but now with the vertical translation, so it's 2 unit down. So 3 minus 2, then that'd be 1. And then this one, negative 3 minus 2, then that'd be negative 5. All the way down to the bottom. So again, 3, don't forget about that. It's not just the initial amplitude or the initial y value for the vertex, but this one, it's the scale factor, so it shows that it's a vertical stretch. So you probably want to identify that as well, vertical stretch, by the factor of 3. So that means the parabola is going to be very skinny. So like this. And this one too, very skinny. Just like that. And that'll be your final graph. And then for the VA, you can always extend it all the way down. Dot it. Dot it. Okay, so that's it. So please let me know any questions that you have, or you can just put in any comments. So again, any things that you have question with, let me know. And please subscribe to the channel, and also tell your friends or people that who are doing the same kind of stuff at their school site, trigonometry. So eventually, sooner or later, you guys are going to be dealing with this. If that's not trig, that means it's going to be in pre-calc. Okay, so thank you for watching it, and I'll see you guys next time. You guys take care.